You've learned about hexagonal architecture and you've built this nice, clean hexagonal service. You've got ports and adapters. You've adopted every pattern you need to. Everything looks fantastic locally. Then someone says to you, now you need to deploy that. So how would you actually go about deploying that service that you've built using hexagonal architecture? Because everything starts to get confusing at this point, right? You've got containers, you've got load balancers, you've got Kubernetes, you've got service meshes, you've got all these choices, and suddenly every single decision you make feels critical. So how would you actually go about making that decision?
I think you've accidentally built a platform, James. And I think in lots of cases, you don't need to build a platform at the start. You just want to deploy a service somewhere and have it run.
Sure, but like, surely the answer to that then is let's just spin up a virtual machine and run it there and expose an endpoint and cool. Like, that's that, right? Feels like if I'm going to do that, I'm kind of going back to the 1960s and I'm doing things in a way that's got no portability, no structure, and no real way for things to start calling each other.
You can certainly just deploy a virtual machine, although I think these days, why not just make things boring and deploy a container? A good way of getting started with that, I think, is looking at the 12-factor ACT principles these days. It basically provides a fairly definitive set of rules for how you should structure an application as a deployable unit so that you have flexibility with where you run it and so that it operates in a reasonably idiomatic way. For instance, one aspect of it that I think is super relevant is configuration. So basically the idea that your application should contain its own configuration, it should be stored in the environment. There's a bunch of these kind of like high level ideas about how to do things, and you can click into them and see more concrete information about this. So for instance, if you talk to a database, you should provide the database configuration through environment variables typically. So with this plus containers, you can end up in a very robust, flexible situation for deploying your application without having to build an entire Kubernetes platform from the ground up.
Which I guess is right. And 12 factor app sounds super interesting, but even with all of that, like you could 12 factor your app to the nth degree, but you still need to then run that app somewhere, right? If I understand correctly what the 12 factor app is, this is just a way of like designing or thinking about restructuring your application, kind of similar to hexagonal architecture, but we still need to run it somewhere, right?
Yeah, so you still need a deployment target, but because you're deploying a Docker container ultimately at the end of the day, you're decoupling yourself from the concrete provisioning of the infrastructure behind it and how you talk to the different components like databases. You don't really need that much at the end of the day. You need a deployment target, which means in practice for synchronous services, you're going to need a load balancer. You're going to need probably an SQL database. Maybe you need some object storage. That's pretty much it.
Right. But the, that's pretty much it is a pretty loaded term, right? There's still a million different options. Are you going to, I know you said like, you know, you don't necessarily need a Kubernetes platform, but that is one such way to run this, right? Are you going to self-host Kubernetes? Are you going to use serverless and serverless functions? Are you going to use serverless containers? Are you going to use which cloud provider are you going to use to do all of this? Like there's still with that statement of, hey, this is easy now. We've got a deployment target. There's still a awful lot of decisions there, right?
Yeah, I mean, there's lots of different, plenty capable tools. I think you're going to end up in this pattern where you over-index on spending lots and lots of time comparing things that at a very high level are very similar to each other. For instance, should I be using AWS today? Should I be using GCP? Let's spend weeks testing all of the different stuff. And this is kind of also an advantage or like maybe a perverse advantage of containerization because you've decoupled yourself back from the infrastructure so much. You have lots of choice with this. But let's start simply. You work in a company, presumably. Is there prior art in the company you're at? Is everyone using AWS and ECS? Is everyone using Google Cloud Run? Probably you should just do that unless you have a really strong, compelling reason to do something completely differently. If you have a platform team, if you've been lucky enough that your company is so big, some other folks handle this for you and they provide a nice abstraction over, say, Kubernetes, you should probably just use that rather than saying, Kubernetes is too complicated for me. There's no benefit here because they've abstracted it away and they've provided a consistent way of using it within the organization. And if there's not prior art, I think you just start with whatever the simplest abstraction you can get away with. This typically means these days the serverless container orchestrators, so things like Google Cloud Run, things like ECS Fargate and AWS. Kubernetes is for sure a very big, capable hammer, but failing some clear driver to use it, like it's already being used broadly internally, or you need to run on self-hosted hardware or what have you, I would say it's a fairly funny place to start. It makes run this ordinary Docker container much harder than it can possibly be.
For sure. Although it's interesting, I was at a serverless conference a few years ago, and there was somebody there who was, to your point about like, is there prior art? Their whole organization was all Kubernetes. Everything was Kubernetes, but he never saw Kubernetes as a developer. He packaged his container and pushed it, and magic happened. And he was like, "Does that mean I'm serverless?" It's like, I guess. But yeah, for the most part, I kind of agree with your point. Like, there's no prior art. There's nothing else. The simplest abstraction. Assuming now, let's say I don't know, we're an AWS shop. We're going to run Stickerlandia on AWS. We're going to use ECS Fargate to run our hexagonal ports and adapters design services. But there's still more to it than that, right? Like the application, the stateless container doesn't exist on its own. It has other services it needs to call, whether that's other cloud services, whether that's other microservices, whether that's databases. Are we just going to push everything into this one big container now then? Or is there's some other option or something else that we can do here?
No, no, do not put everything into one big container. This is kind of an anti-pattern. Generally, you would want to deploy all of your services as independent containers from one another. There's kind of an exception for so-called sidecar containers. Like if you have an observability collector, you typically run that using the platform's ability to model multiple containers running in like one deployable unit as a separate process that can talk directly or be talked to directly from your service itself. So concretely, what you really want to do is establish a base pattern for deploying an individual service to some particular container orchestrator or platform, and then use that same platform over and over for everything. You might also have a point where you say, hey, these services are internal, these services are external. In some cases, for the external ones, we publish them in directly from a public load balancer. For the internal ones, maybe we have an internal load balancer. But apart from that, this is a very generic pattern that you extend over all of your applications, which are independently deployed to each other.
Yeah, I think for in a lot of cases, like the public facing one is kind of easy to wrap your head around because you just you put a load balancer, it's got some DNS name, and that's that. Like it's publicly available. Happy days. I think the inter-service, like the internal stuff, can get interesting, tricky, challenging because the simple solution might be, maybe you need some kind of load balancer still there, but there's other considerations that, like if I'm thinking, I'm working in an organization that's got hundreds of microservices, 50% of them are synchronous services, you're exposing them all internally on load balancers. They've all got their own DNS names from their own load balancer, and now the things actually know how to talk to each other.
Yeah, I think there's kind of like two ways of doing service discovery for internal services. The proxy style, where you have a load balancer, like you say, and maybe you have like an internal load balancer with parts for your internal services behind it. You deploy it internally, so it can only be accessed by other services. Or maybe you have a load balancer per service. There's often negative cost implications for doing that with some of the platforms. The other way around is that you make it a kind of a DNS concern so that you have these pointers by service name, like I'm the identity service. I can resolve that. And from the DNS service, you get back a very short-lived record that points at one or more endpoints. Yeah. So whenever you connect, you often get a new endpoint. And this is generally implemented by clouds internally via some specially named mechanism. Like in AWS ECS, I think it's called Service Connect. Yeah. So you can say, hey, these are internal services. I want them to be discoverable from other containers under this name. And it all just magically works out. This is a nice option to use, particularly for internal things where you don't need like this big unified public load balancer.
Yeah. I know we just said that assuming we're going to deploy Stickerlandia to AWS, but actually the bit of work I've done with Azure recently, particularly Azure Container Apps, makes this like the easiest possible thing I've ever implemented. Like you have a container apps environment, dev, prod, staging, whatever. You deploy your individual container apps inside that environment. So let's say we've got orders and we've got payments, for argument's sake. Because they are inside the same environment, they can just magically call each other. So the orders could just say, make a HTTP call to payments.myMagicContainerApp domain. It might even just be payments, HTTP calls that as payments. That's it. And because you've got a container app inside that environment with that name, it like also resolves the DNS. It's very, very cool for like this inter-service communication stuff.
Nice. I mean, you could also go really hard and everyone could just build everything on Erlang ODP, which makes this all work very nicely, but maybe that's not.
Well, the magic of AI means we can do that with everything now, right? We can whatever language we want. Sure.
Absolutely. But yeah, so then the other part is for the actual ingress from the public into your API, right? So you have a bunch of services that you internally treat as kind of independent units that you think of independently, but for the public, you don't want to do that. You want a consistent API. What I think generally works well as a good starting position is to just have prefix-based routing off of a single public load balancer. So you have your subdomains, like we have API stickers v1, we have API awards v1, we have API user management v1 for Stickerlandia. We impose kind of an overall high-level URL scheme on things. And then in our API gateway configuration, we can just say, hey, if it's this prefix, send it to this service. If it's this prefix, send it to that service. Because the services themselves use the same URL scheme, you also don't have to do URL rerouting, which makes things work very nicely. And back to the cost thing, you have like one public load balancer that runs everything, and consistency, a single API from a user experience perspective, which is nice.
That sounds pretty pragmatic, actually, Scott. So I guess for anyone listening, like, what's the kind of wrap up for, you've built this magical hexagonal service, you've thought about how to structure your code base, you've designed it, you've packaged it up as a container, like what next? How do I run that service?
So I think step one is pick a platform and be pragmatic based on what's already in your organization. Build all your services independently to Docker images, release them somewhere. There's a whole rabbit hole there, but we'll just wave over that for the second. Use 12-factor to think about how your container images should actually look, like in particular in terms of the environment, how they should be configured, how they should push observability data out, all of that sort of stuff. And probably start with serverless container orchestrators to start with, unless you know better, just because there's lower operational burden, it's going to be easier to get going. You're going to spend more time building your application and less time bike shedding Kubernetes operators.
Yeah, I'm going to keep shivering every time you say Kubernetes. But yeah, I guess to get really specific there, if this is an AWS shop, it's like ECS Fargate. If you're a Azure shop, it's things like Azure Container Apps, Google Cloud Run. Like most, if not all, the cloud providers now have a way to say, here's a container image, make it go. And if you do want to see some of this in practice, then the link to the Stickerlandia repository is in the description below. There's examples of how to do this with the AWS CDK, how we use shared constructs to, as Scott mentioned at the start about, if the platform engineering team provides an abstraction to deploy some of this stuff to do it all in a reusable way. There's examples of that in the repository linked in the description below. And with that, we'll see you in the next one.